Example 5.1 is asking us firstly to find the derivative or find the gradient function of the following equations and to find the gradient of the tangent at the point x equals 2. Now, there are no instructions to use first principles, so when there's no instructions to use first principles, don't use them. All right, so our derivative, I beg your pardon, f dash of x is going to be, on our first term, the 4 comes down as a factor, x, 4 minus 1 is 3, plus 3 times 4, in fact I'll just do it all in one go, 3 times 4 is 12x squared, and the minus 500 is a constant, so it derives to 0, and we don't write the 0. And that's it. When it's asking us the gradient of the tangent at the point 2, what we're doing is f dash of 2, which is 4 times 2 cubed plus 12 times 2 squared. 2 cubed is 8 times 4 is 32. 2 squared is 4 times 12 is 48. 32 plus 48 is 80. So the slope of the tangent at x equals 2 is 80. All right, having a look at this next little one, it's quite a bit more complicated, and suddenly we're going, oh, that's not quite the same rule. How on earth do I do that? Well, the first thing that we need to recognize is that when we're doing these, oh, my whole thing has moved. When we're doing differentiation, this rule, which is the basic rule, if f of x equals ax to the n, then f dash of x equals ax to the n minus 1, it only applies to x terms in the numerator. You cannot apply these to anything that's in the denominator. So before we can do any differentiation on something like this, we need y equals 3x minus 5 on x cubed. We need to tidy it up so that we can get the x into the numerator. The first thing we recognize is that this x cubed is dividing both the 3x and the minus 5. So it's 3x divided by x cubed minus 5 on x cubed. From there, we should recognize using our index laws, and this is why I've put a reminder of your index laws, that 3x divided by x cubed is actually going to be 3 on x squared minus 5 on x cubed, and that is in fact 3x to the minus 2 minus 5x to the minus 3. Once we've tidied it up as much as we can and all of our x's are in the numerator and only the numerator, then we can do our differentiation. So if this is the function that we're now differentiating, it's exactly the same as all of the others, just expressed differently. So then we can say that y dash is minus 2 times 3 is minus 6, x minus 2 decreased by 1 is minus 3. Then our second term, minus 5 times minus 3 is plus 15. X minus 3 decreased by 1 is minus 4. You can leave it like that, or you can rewrite it to minus 6 on x cubed plus 15 on x to the power of 4. Then we can let x equal 2. When x equals 2, y dash is going to be negative 6 on 2 cubed plus 15 on 2 to the 4, which is going to be negative 6 on 8 plus 15 on 2 cubed is 16. So it's negative 12 on 16 plus 15 on 16, which is going to be 3 on 16. And that's it. All right, for the next video, I'll start another video and we'll go through the rest of example 5.1.